the LRM, Large Reconstruction Model for Single Image to 3D. We propose the first large reconstruction model, LRM, that predicts the 3D model of an object from a single input image within just 5 seconds. In contrast to many previous methods that are trained on small-scale datasets, such as ShapeNet in a category-specific fashion, LRM adopts a highly scalable transformer-based architecture with 500 million learnable parameters to directly predict a neural radiance field, NeurF, from the input image. We train our model in an end-to-end manner on massive multi-view data containing around 1 million objects, including both synthetic renderings from Objaverse and real captures from MVimageNet. This combination of a high-capacity model and large-scale training data empowers our model to be highly generalizable and produce high-quality 3D reconstructions from various testing inputs, including real-world in-the-wild captures and images from generative models. Video demos and interactable 3D meshes can be found on the project's website. MPlugOwl2, Revolutionizing Multimodal Large Language Model with Modality Collaboration. Multimodal large language models, MLMs, have demonstrated impressive instruction abilities across various open-ended tasks. However, previous methods primarily focus on enhancing multimodal capabilities. In this work, we introduce a versatile multimodal large language model, MPlugOwl2, which effectively leverages modality collaboration to improve performance in both text and multimodal tasks. MPlugOwl2 utilizes a modularized network design, with the language decoder acting as a universal interface for managing different modalities. Specifically, MPlugOwl2 incorporates shared functional modules to facilitate modality collaboration and introduces a modality adaptive module that preserves modality-specific features. Extensive experiments reveal that MPlugOwl2 is capable of generalizing both text tasks and multimodal tasks and achieving state-of-the-art performances with a single generic model. Notably, MPlugOwl2 is the first MLLM model that demonstrates the modality collaboration phenomenon in both pure text and multimodal scenarios, setting a pioneering path in the development of future multimodal foundation models. 3D Diffusion, 3D object detection with geometry-aware diffusion features. We present 3D Diffusion, a state-of-the-art method for 3D object detection from single images, leveraging features from a 3D-aware diffusion model. Annotating large-scale image data for 3D detection is resource-intensive and time-consuming. Recently, pre-trained large image diffusion models have become prominent as effective feature extractors for 2D perception tasks. However, these features are initially trained on paired text and image data, which are not optimized for 3D tasks and often exhibit a domain gap when applied to the target data. Our approach bridges these gaps through two specialized tuning strategies, geometric and semantic. For geometric tuning, we fine-tune a diffusion model to perform novel view synthesis conditioned on a single image by introducing a novel epipolar warp operator. This task meets two essential criteria: the necessity for 3D awareness and reliance solely on posed image data, which are readily available, for example, from videos, and does not require manual annotation. For semantic refinement, we further train the model on target data with detection supervision. Both tuning phases employ ControlNet to preserve the integrity of the original feature capabilities. In the final step, we harness these enhanced capabilities to conduct a test-time prediction ensemble across multiple virtual viewpoints. Through our methodology, we obtain 3D-aware features that are tailored for 3D detection and excel in identifying cross-viewpoint correspondences. Consequently, our model emerges as a powerful 3D detector, substantially surpassing previous benchmarks. For example, CubeRCNN, a precedent in single-view 3D detection by 9.43% in AP3D on the Omni3D ArxivDailyScene dataset. Furthermore, 3D Diffusion showcases robust data efficiency and generalization to cross-domain data. TEAL, Tokenize and Embed all for multimodal large language models. Despite multimodal large language models, LLMs have made exciting strides recently, they are still struggling to efficiently model the interactions among multimodal inputs and the generation in non-textual modalities. In this work, we propose TEAL, Tokenize and Embed All, an approach to treat the input from any modality as a token sequence and learn a joint embedding space for all modalities. Specifically for the input from any modality, TEAL first discretizes it into a token sequence with the off-the-shelf tokenizer and embeds the token sequence into a joint embedding space with a learnable embedding matrix. LLMs just need to predict the multimodal tokens auto-regressively as the textual LLMs do. Finally, the corresponding detokenizer is applied to generate the output in each modality based on the predicted token sequence. With the joint embedding space, TEAL enables the frozen LLMs to perform both understanding and generation tasks involving non-textual modalities, such as image and audio. Thus, the textual LLM can just work as an interface and maintain its high performance in textual understanding and generation. Experiments show that TEAL achieves substantial improvements in multimodal understanding and implements a simple scheme for multimodal generations. Holistic evaluation of text-to-image models. The stunning qualitative improvement of recent text-to-image models has led to their widespread attention and adoption. However, we lack a comprehensive quantitative understanding of their capabilities and risks. To fill this gap, we introduce a new benchmark, Holistic Evaluation of Text-to-Image Models, HIM. Whereas previous evaluations focus mostly on text-image alignment and image quality, we identify 12 aspects, including text-image alignment, image quality, aesthetics, originality, reasoning, knowledge, bias, toxicity, fairness, robustness, multilinguality, and efficiency. We curate 62 scenarios encompassing these aspects and evaluate 26 state-of-the-art text-to-image models on this benchmark. Our results reveal that no single model excels in all aspects, with different models demonstrating different strengths. We release the generated images and human evaluation results for full transparency at the project's website and the code at the project's website, which is integrated with the Helm codebase. Everything of thoughts, defying the law of Penrose triangle for thought generation. Recent advancements in large language models, LLMs, have revolutionized decision-making by breaking down complex problems into more manageable language sequences referred to as thoughts. An effective thought design should consider 3 key perspectives: performance, efficiency, and flexibility. However, existing thought can at most exhibit 2 of these attributes. To address these limitations, we introduce a novel thought prompting approach called Everything of Thoughts, XOT, to defy the law of Penrose triangle of existing thought paradigms. XOT leverages pre-trained reinforcement learning and Monte Carlo tree search, MCTS, to incorporate external domain knowledge into thoughts, thereby enhancing LLM's capabilities and enabling them to generalize to unseen problems efficiently. Through the utilization of the MCTS LLM Collaborative Thought Revision Framework, this approach autonomously produces high-quality comprehensive cognitive mappings with minimal LLM interactions. Additionally, XOT empowers LLMs to engage in unconstrained thinking, allowing for flexible cognitive mappings for problems with multiple solutions. Next chat, an LLM for chat, detection and segmentation. The development of large language models, LLMs, has greatly advanced the field of multimodal understanding, leading to the emergence of large multimodal models, LLMs. In order to enhance the level of visual comprehension, recent studies have equipped LLMs with region-level understanding capabilities by representing object-bounding box coordinates as a series of text sequences, pixel to sequence. In this paper, we introduce a novel paradigm for object location modeling called pixel to embedding method, where we ask the LLM to output the location embeddings and then decode it by different decoders. This paradigm allows for different location formats, such as bounding boxes and masks, to be used in multimodal conversations. Furthermore, this kind of embedding-based location modeling enables the utilization of existing practices in localization tasks, such as detection and segmentation. In scenarios with limited resources, our pixel-to-embedding method demonstrates superior performance compared to existing state-of-the-art SOTA approaches in both the location input and output tasks under fair comparison. Leveraging the proposed pixel-to-embedding method, we train an LLM named NextChat and demonstrate its capability of handling multiple tasks like visual grounding, region caption, and grounded reasoning. Can LLMs follow simple rules? As large language models, LLMs, are deployed with increasing real-world responsibilities, it is important to be able to specify and constrain the behavior of these systems in a reliable manner. Model developers may wish to set explicit rules for the model, such as do not generate abusive content, but these may be circumvented by jailbreaking techniques. Evaluating how well LLMs follow developer-provided rules in the face of adversarial inputs typically requires manual review, which slows down monitoring and methods development. To address this issue, we propose rule-following language evaluation scenarios, rules, a programmatic framework for measuring rule-following ability in LLMs. Rules consists of 15 simple text scenarios in which the model is instructed to obey a set of rules in natural language while interacting with the human user. Each scenario has a concise evaluation program to determine whether the model has broken any rules in a conversation. Through manual exploration of model behavior in our scenarios, we identify 6 categories of attack strategies and collect 2 suites of test cases. One consisting of unique conversations from manual testing, and one that systematically implements strategies from the 6 categories. Across various popular proprietary and open models, such as GPT-4 and Llama 2, we find that all models are susceptible to a wide variety of adversarial, handcrafted user inputs, though GPT-4 is the best performing model. Additionally, we evaluate open models under gradient-based attacks and find significant vulnerabilities. We propose rules as a challenging new setting for research into exploring and defending against both manual and automatic attacks on LLMs. GENOME, Generative Neuro-symbolic Visual Reasoning by Growing and Reusing Modules. Recent works have shown that large language models, LLMs, could empower traditional neuro-symbolic models via programming capabilities to translate language into module descriptions, thus achieving strong visual reasoning results while maintaining the model's transparency and efficiency. However, these models usually exhaustively generate the entire code snippet, given each new instance of a task, which is extremely ineffective. We propose generative neuro-symbolic visual reasoning by growing and reusing modules. Specifically, our model consists of 3 unique stages: module initialization, module generation, and module execution. First, given a vision language task, we adopt LLMs to examine whether we could reuse and grow over established modules to handle this new task. If not, we initialize a new module needed by the task and specify the inputs and outputs of this new module. After that, the new module is created by querying LLMs to generate corresponding code snippets that match the requirements. In order to get a better sense of the new module's ability, we treat few-shot training examples as test cases to see if our new module could pass these cases. If yes, the new module is added to the module library for future reuse. Finally, we evaluate the performance of our model on the testing set by executing the past programs with the newly made visual modules to get the results. We find the proposed model possesses several advantages. First, it performs competitively on standard tasks like visual question answering and referring expression comprehension. Second, the modules learned from one task can be seamlessly transferred to new tasks. Last but not least, it is able to adapt to new visual reasoning tasks by observing a few training examples and reusing modules,